Everyone. I am Dr. Biswajit Mahanti, Associate Professor, Department of Electronics and Communication Engineering, SR University, Warangal, Telangana, India. You are welcome to my YouTube channel. Few previous classes, we are continue information theory and coding. We have completed the definition of entropy, average information, rate of information, and their numericals, Markov chain, Markov statistical methods with examples. We have also finished Hammond coding technique and Shannon-Fano coding techniques and their corresponding numericals. Today, I am planning to give one more important numerical that will help you for your semester exam, mid-sem, or gate exam, or any other competitive exams. Not only related to our electronics and communication engineering, but also some computer science, information technology, trivially programs students also can benefited for this particular last few from past few videos. So today's numerical is, I'm writing here. So we are giving you a table. So first you write the numericals, then we'll go for solutions. The following table shows the joint probabilities joint probability distribution of two random variables x and y with respective values xi and yi. The problem is calculate all types of entropies, all types of entropies like h of x, h of y, h of x comma y, h of x by y, h of y by x. So we'll start solution. So the following tables, so I should show the table first. This is table, then we'll go for solution. This is y1, y2, x1, x2, x1, x2, x3. Corresponding probability, this is half, this is 1 by 8, this is 1 by 8, this is 1 by 8, 1 by 8, and this is 0. This is given. Now we'll go for solution. So answer. First one, number 1. marginal distributions. Marginal distribution. Marginal distribution. So I am requesting my dear students to follow this video, and it is very much useful and important for your upcoming semesters. Now for x, we will calculate marginal distribution for x first, then we will go for y. So for x, we will find out probability of x1, we will find out of probability of x2, we will find out of probability of x3, these three. So how we will calculate probability of x3, x1, x2, x3? So probability x1, half plus 1 by 8. So half plus 1 by 8. Probability of x2, for x2, 1 by 8 plus 1 by 8. 1 by 8 plus 1 by 8. Please follow me. And probably x3 means 1 by 8 plus 0. 1 by 8 plus 0. So this is, that would be 5 by 8. If we calculate, this will be 1 by 4. And this is obviously 1 by 8. We got marginal distribution for x, and similarly now we will go for y. So probability of y1, probability of y2, and probably y2 only, because y1 and y2. So here no y3. So here no y3. Now simple, this is probability of y1, it should be this side, it should be horizontal side, this side and this side. So half plus 1 by 8 plus 1 by 8. So it should be half plus 1 by 8 plus 1 by 8. For this, 1 by 8 plus 1 by 8 plus 0. 1 by 8 plus 1 by 8 plus 0. So that will give you 1 by 8, 1 by 8, 1 by 4, 1 by 4 plus 1 by 2. So 3 by 4. And this will give you 1 by 4. So we got probability of x1, probability of x2, probability of x3. Similarly, we got probability of y1 and probability of y2. So this is most important. Hope my dear student understood. Now we'll go for entropy calculation. Number 2, entropy. Entropy. We know the formula of entropy. What is that? Entropy E is equal to, of any system, minus summation over, it should be k is equal to 1 to n pk log to the base pk. Is the formula. If we remove negative sign, then it should be like that, k is equal to 1 to n pk log to the base 1 by pk. So depending on our situation, our mood, you can use. It's not like that we can't use either or. Any one we can use, either this or this. So now for the timing, we are going to calculate using this formula, minus 1 k is equal to 1 to n p of k log to the base p of k. So we will find out entropy for or of x, entropy of x, that is h of x. So that should be minus summation over k is equal to 1 to, how much is there? There x value how much? 1, 2, 3. So 3 values are there. So 1, 2, 3 pk log to the base pk. So that means 3 minus is outside. So first probability into log to the base first probability, like this. So what are the probabilities? This is 5 by 8. So 5 by 8 log to the base 5 by 8. Similarly, plus second probability 1 by 8, 1 by 4 plus log to the base 1 by 4. 1 by 4 log to the base 1 by 4 plus last probability is 1 by 8 is 1 by 8, this one 1 by 8 plus 1 by 8 log to the base 1 by 8. Now if we calculate it using calculator, you may calculate, so it will give you, if we calculate it, it should be how much? It will give you 1.30 bits per message. So this is the entropy for x. For x. Now we'll go for calculating. So number 2 finished. So now we'll go for 2 is finished. So h of x is equal to 1.30 bits per message. That we get. This is important. Now we'll go for 3. That is entropy of y. That is h of y. That is h of y. And now we know that h of y is equal to summation over k is equal to 1 to n pk log to the base pk with negative sign. So here how many probabilities? 2 probabilities are there. 3 by 4 and 1 by 4. So 3 by 4 and 1 by 4. So h of y is equal to minus summation over what I told you, 3 by 4. So 3 by 4 log to the base 3 by 4 plus what I told you, 1 by 4. So 1 by 4 log to the base 1 by 4. So now you want to calculate it. What should be the result? So if we calculate it, please you people calculate it. You can pause the video and you try to solve the numericals. So if you calculate it, it will give you 0.81 bits per message. So this is for entropy y. So finally, therefore h of y is equal to 0.81 bits per message. So this is also biggest important. This is from 3. So we got h of x, we got h of y. Now we will calculate joint entropy 4. What that? Joint entropy. Joint entropy, that is h of x comma y. So non-zero, what is that? Non-zero joint probabilities are that means non-zero joint probabilities. So non-zero joint probability, no, what I am writing is the same. Non-zero joint probabilities. What is this? Non-zero. So all are non-zero. Half, 8 by 8, 1 by 8, 1 by 8, 1 by 8. These are. So first is 1 by 2, then 1 by 8, 1 by 8, then again 1 by 8, then 1 by 8. How many? 1, 2, 3, 4, 5. One, two, three, four, 5. So what is the formula for joint probability? So joint probability h of x comma y, that is equal to formula minus summation over That is also k is equal to 1 to n. P of x comma y into log to the base P of x comma y. The same formula. X comma y log to the base x comma y. And these are the x comma y. That is here x1 y2, sorry y1, x1 y1, x2 y1, x3 y1, this element, x1 y2, x2 y2, x3 y3. So that will be the values, this element, like this. We can write this if we make a matrix here. So we can write x1 comma y1, this is x2 comma y1, then x3 comma x3 comma y1, and again x1 comma y2, x1 x2 comma y2, x3 comma y2. Here y1 like this. So that means this value is half, 1 by 8, 1 by 8, 1 by 8, 1 by 8 and 0. So how many probability? 1, 2, 3, 4, 5, 6. But last one x3 comma y2, that is 0. So that's why here we can write all non-zero. So minus half log to the base half plus 1 by 8 log to the base 1 by 8 plus 1 by 8 log to the base 1 by 8 plus 1 by 8 log to the base 1 by 8. So how much 1 by 8? 1, 2, 3, 4. So 1, 2, 3, one more, 4. So we can easily do that. 1 by 2 half log to the base half log to the half, and 1, 2, 3, 4. 4 into 1 by 8 log to the base 1 by 8 we can do. Anyway, so if we calculate it, it will give you 2.00 bits per message. So ultimately, joint entropy hx comma y, which x comma y is equal to 2.00 bits per message. That is most important. Very, very important. So 4, joint entropy hx comma y finished. Now 5, fifth. What is fifth? Fifth is conditional entropy. What is that? Conditional h of x by y. This is conditional entropy. So conditional entropy, this is much important. Now we know that the conditional entropy h of x y can be written as h of x y, that is equal to h of h of x comma y x comma y minus h of y. So x comma y minus h of y, then we get x by y. So h of x comma y we got how much? 2. This one 2.00 minus h of y. How much we got? H of y is equal to this 0.08. 0.81. So if we calculate, it will give 1 minus 1.19 bits per message. Therefore, h of conditional x comma y, that conditional entropy hx comma y is equal to 1.19 bits per message. So fifth is finished. Now sixth. Again conditional sixth. Conditional entropy. Conditional entropy h of y by x. So this one, h by x. As we know, the conditional probability h of y by x here can be written as h y by x h y by x, that is equal to, as per formula, h of x comma y minus h of x. H of x. This is important. But what is h of x comma y? H of x comma y. This one only. 2.00 bits per message minus h of x. H of x is equal to 1.30. This is 1.30. So 0.70 bits per message. Therefore, h of y by x is equal to 0.70 bits per message. This is the final formula. So this is our final expression. So what we get is that this numerical, this is numerical problem 1. Calculate all types of entropies like hx we calculated, hy we calculated, hx comma y calculated, hx comma y, hy by x, y by x, and hx, hy, hx comma y, hx comma y, h x by y, h x by y, this is correct only, h x by y, h y by x. So these all entropies we have to find out. Given that this is two random variables x and y, they are representing each other as elements. 12, 40, 12, 1 by 8, 1 by 1 by 2, 1 by 8, 1 by 8, 1 by 8, 1 by 8 and 0. So we can represent this. Okay. Then first one we calculated marginal distribution of x and for y, x and y. So P of x, P of x1, P of x2, P of x3 we have calculated. Now P of y1, P of y2 we have calculated, important. Then entropy, simple entropy. So for x, entropy for x we calculated, this is entropy for y we calculated. Then joint entropy hx comma y, that also we have calculated, and we got this value. That conditional probability hx by y, so that also we have calculated, hx by y, and we got this is the final result, 1.19. Then sixth, again conditional entropy hy by x, and we calculated using this formula, and ultimately we get this is the final result. So this is all about these numericals. Now we will go for very small numerical, probability problem 2, very simple only. What is that? Consider a DMS, means discrete memoryless system. Discrete memoryless system. I have explained what is discrete, what is memoryless, what is system. With source probabilities. Source probabilities, how much? Source probability 0.30, 0.25, 0.20, 0.15, 0.10. Find, the numerical is that, find the source entropy h of x. This is very good question, very simple question. We have derived many numericals already. All are entropy, so this is very simple only, na? Because this kind of entropies we have calculated, hx, hy, hx comma y, hx by y, hy by x. So joint probability and conditional probability we have calculated. So we know that h of x is nothing but minus summation over p of k log of 2 the base pk. So your probabilities are this. So minus, first one is 0.30 log 2 the base 0.30 plus 0.25 log 2 the base 0.25 plus third one 0.20 log 2 the base 0.20 plus 0.15 log 2 the base 0.15 plus 0.10 log 2 the base 0.10. So this is the formula. What do you get? So now we have to calculate 0.30 log to the base 0.3. Similarly, 0.25 log to the base 0.25. Here this is log to the base. Log to the base. So that will be the answer. So whenever probability comes, we will use this formula only. So this one. So we have finished our two numericals, and these two numericals both are useful and very important. So I shall give you one more numerical and you try to solve at your home. Probability problem 3. Problem 3 is that is discrete source transmits messages x1, x2 and x3 with the probabilities the probabilities 0.3, 0.4 and 0.3. The source is connected to where it is connected to the channel given in the below figure. Now what is the question? Question is calculate all the entrophies. What I mentioned is that already we have calculated in our problem 1. Okay. So just I am giving the figure 1, 2, 3. This is x1, x2, x3. This is y of 0, y of 1, y of 2 and y of 3. It is something like that. Take another color. This is connected to y1 and y2. It connected to y1 and y2. So like this. This is directly connected. Okay, and this is connected to this and this. Okay, now we'll tell the probability. Probability with different color. 0.8. This is 0.2. This is 1 and this is 0.3 and this is 0.7. So this figure is given figure. Okay. So now solve. So I will give you the result. Answer. What you people solve. What is answer? Probability in question is given probability of x1, probability of x2 and probability of x3. This is given in the numericals itself. 0.3, 0.4 and 0.3. This is given in the numericals. Now probability of y1, probability of y2, probability of y3. I am giving the answer only. So probability of y1 is 0.24, then probability of y2 is equal to 0.55 and probability of y3 is 0.21. So that is also given. Now probability of x sorry, entropy of X, that is given 1.571 bits per message. Probability of y, 1.441 bits per message. These are the answer I am giving you. You please practice it at your home. Now, probability of x comma y, joint probability, entropy of x comma y, that will be the answer 2.053 bits per message. H of x by y, h of x by, like this, conditional probability, h of x by y, y by x, conditional probability. So h x by y, the result is 0.612 bits per message, and h of y by x, that is equal to 0.482 bits per message. So my dear student, this is very important, these numericals. So please solve all these problems. So this is VVI. Please do it, solve it. Any doubt, mention me in the YouTube channel. Definitely I will communicate one by one directly to that particular student. So hope you people understand. So if you like my channel and videos, don't forget to like, comments and share. And if you wish to have your desired topic and course, then you tell me. I will provide you with that particular topic and that particular course. So thank you all for your support. So thank you all.